In day 2 for 8.2, we're actually going to undo what we did in 8.2a. Before I even start, we're going to first discuss this word here for a second. If I were to ask you right now on this fly here, factor 15, 90% of you, I'm sure, would say it's equal to 3 times 5. So you would say, well, I learned how to make factor trees, and that's totally true. That's how we factor a number. We break it into two numbers that when multiplied equal it. It really means to break it apart into a multiplication problem. So I'm going to write that down. To break it into, and I purposely am using a pronoun here because I could factor numbers, I can factor polynomials. So I'm purposely using that word it because it just means to break it, the expression, I suppose I could have said, into a problem, or into a product, multiplication. So when I say factor 12, you'd say 2 times 6. Or you could say 4 times 3 or 12 times 1, and we break it into multiplication. Well, that's the exact same thing we do when we factor a polynomial. We break apart. There's just different kinds of factoring that we need to do with our polynomials. So today we're going to be doing what's called factoring out a common monomial. And recall, monomial is a one-termed polynomial. So let's review what we did yesterday, because yesterday we actually multiplied by a monomial. And we said to do that, you distribute that 3x in. So notice I'm multiplying a 3x into both terms. And when I do that, I get 3x to the third because of the 1 plus 2. When I multiply, I add the exponents, minus 18x. That is called multiplying. And I did that by distributing. Now, when we talk about factoring, what we do is we say, well, let's suppose, don't do this in your notes, I didn't know what this original multiplication problem was, and I was given that. Let me give you the numerical equivalent. What's 5 times 3? You would say 15. What I'm doing now is I'm saying, what if I give you 15 and tell you to break it into multiplication? You'd say 5 times 3. So they are processes that undo each other. So, however, this isn't quite as obvious how to factor as factoring the number 15. So how do we factor that? How do we get back? Notice I crossed it off. How do I get back to see what was that? I break it into multiplication. And to do that, we're in search of what we call a greatest common factor. The biggest thing that goes into or divides evenly into both terms. So basically what we've got here is I distributed something in and now I'm going to factor it out. They undo each other. It's like you go full circle. Well, how do it was easy to distribute it in. I just hopped it on in. But once it's in, how do I figure out what to pull out? Well, this is what we do. We need the biggest number, hence the G for greatest, and the highest degree of variables which fit. And that's not a good math term, but basically it means they go into every term. They divide into it evenly. So let's go just talk about GCFs for a moment. I need to know what I can pull out of every term. See, you hop it in when you're multiplying, you pull it out when you're factoring. So what number can I pull out of all of these coefficients? 5, and you should be comfortable with that vocabulary term now. 10 and 35. Well, 5 goes into each one evenly. The next question is, how many x's can I pull out without robbing anybody? What's the most everybody can give me? Well, you might say 3. Nah, because this one doesn't even have any. They all have to be able to give me that amount. And you'll notice I can't take any out because 35 doesn't have any x's on it here. So my greatest common factor for that one is simply the number 5. But now let's take a look over here. What is my greatest common factor on this one? What number can I pull out of every single term? And you look at 3, you look at 12, and you look at 18. And you have to, actually, I like to start with the smallest one because nothing goes into 3 except for 3. So 3 goes in here, and it goes here. So 3 is the biggest number they can all have divided out of them. Now, how many A's? If I said, you guys each got to give me an A, how many can they give me? Can they all give me 2 or 3? And the answer is nope, they can just give me 1. So really, when you're looking for how many variables you can pull out, it's the smallest power that you see. Repeat that. It's the smallest power that you see. Because you have to go to the lowest common amount. If somebody has a $5 bill in their wallet, and the person next to you has a $10 bill, the person next to him has a $20 bill, and I say, you guys all have to give me the same, you gotta give me 5, because he can give me. So let's go take a look at that. How many B's can you all give me? It's a good question. Can't give me, can't give me any C's. So let's go take a look here. Why my board? I'm gonna let my smartboard get cut up because I really don't want to start video over again. So let me go back here, see if that'll help just to move this forward for a second. All right, so on the bottom, oh dang it, super. So it says create a binomial GCF. What does that mean? Where 8x squared is the biggest thing in it. Well, really, I'll just multiply that by 2, and maybe just do. This isn't a good question, and it's just going to mess you up. I'm going to take that out. So it says once you can find a GCF, you can factor. All right? We're going to go to the next page here, and we're going to practice. All right? So how do we factor? This is our process. We are undistributing. We're trying to figure out what did I hop in to create this. Basically, what I've got here is the answers from yesterday. Yesterday, you multiplied something in and got an answer. Today, I'm saying, what's the answer? 4x cubed minus 12. To what? Something that I multiplied in. I'm going to figure that out. So here I go. What's the biggest number that's in both of these? 4. How many x's can they each afford to give me? None, because 12 doesn't have any. So I'm going to divide that out of both terms. So I'm going to divide a 4 out of this one, giving me x cubed. I'm going to divide a 4 out of that one, giving me a 3. You'll notice if I were to cross that out, I would like to cover it up with my hand, but you can't see that on the video. When I hop this back in, I get 4x cubed minus 12. They are undoing each other. All right, so let's go to the next one. What is the biggest number I can take out of all of these? So 6 has some stuff in it. It's got a 6 in it. That doesn't go into 8. 2 in it. Yes. 3 in it? No. So it's going to be a 2. They're all even. We can always pull a 2 out for sure. And then I need to see if there's anything else. Can they all afford to give me a P? No. Can they all afford to give me a Q? No. So actually my GCF is just that little 2 sitting there. And what am I going to do? I am going to divide it out of every term. Okay, divide out a 2 and I get 6p squared. Divide out a 2 and I get a 4p. So I get divide out a 2 and then minus 3p. Oh, great. You're
You're annoying. Please, you don't need to exit the building.
I'm going to try to get this done
Also,
quickly.
please
So,
steer clear of the doors. They may close.
I'm going to pause this. There you go. I had to pause the video for fire alarm. So anyway, let's go and do one more here. These are kind of easy. I mean, it's not so difficult. Biggest number that goes into all these, obviously just a 2. They do all have y's in them. I'm going to go to the smallest. There's 5, 3, 2, 1. They can only afford to give me 1. Now for each one of these, I'm going to divide out a 2 and a y. Okay? I'm going to divide out a 2 and I'm going to divide out a y. That's going to give me y to the 4th. Notice when I hop that back in, I've got 2y to the 5th. They're so easy to check. Anything that it says factor, you multiply and you'll know if you did it right. Next one, I need to have the subtraction symbol. And then I need to have a 5 when I divide out a 5 and a y squared. I'm going to be knocking each one, a y out of each one of them and a 2. I'm going to knock a 2 out of that, leaving me with a 6, and a y out of that, leaving me with a y. I'm going to knock a 2 out and a y out. Now be careful, tune in here. Because when I divide 2y by 2y, what do I get? 1. Sometimes people won't put anything there, but remember when you hop this back in, you've got to get this back out. So you got to make sure you end that with a 1. All right, last up here, down here. I think it's the last one in this section. Yes, it is. So it says write a factored expression for the area that falls between the square and the helipad. Well, that's basically a factored expression. That's a good word because it means I'm going to need to factor it for the area between the square and the circle. Well, that's this red stuff on the picture here. I want to get in between the circle and the square. And what that means is I'm going to find the area of the square. That'll give me the whole thing. So I'm going to go find the area of that square. What that would do, and again I'm going to show you on the picture, if I found the area of the square, I would have all of this. I don't want all of this. I got to take that circle and erase it out of there. So what math operation would that be? Subtraction. So I need to do the square minus the circle. Area of a square. Oh, sorry. They're on the intercom all the time here, so I keep having to pause the video. So how do I get the area of a square? I do side, or base, times height. So here it is. That's the area of the square. It's the whole thing. Now I'm going to find the area of that circle and subtract it off. I challenge you to write down how you think you get the area of a circle. Pi is in it. A lot of people say 2 pi r. No, that's circumference. Pi r squared is the area of a circle, where r represents the radius. So we're going to be using an x for that. So I'm going to do pi times x squared. So 2 times 2 is 4. X times x is x squared minus pi x squared. Notice it says a factored expression. What that means is there must be something that I can divide out of both of these. It's staring you right in the face. They both have an x squared that we're going to pull out front. Now it's thundering. Boy, everything's going on here today. When we divide x squared out of this one, we have a 4 left, and out of this one, we have pi left. You'll notice when I hop it back in, I get 4x squared minus 4 pi. Phew, there's a lot of stuff going on during this video. I had a fire alarm, 2 messages, thunder, lightning, and I am finally done.